Welcome back to Kamal Kunj Home Academy. Encounter with the art and science of ceramics. In this session, we will discuss about the concept of castable refractories. Now, the castable refractories was manufactured for the first time in USA in 1929 and in Japan in 1939. Refractory castable was manufactured for the first time in 1929 in USA and 1939 in Japan. These castables contain high cement content, and nowadays these are called conventional castables. Now, these conventional castables have some drawbacks. These castables are called conventional castables, conventional or regular castables. And these castables have some drawbacks. Some drawbacks. These drawbacks are these castables contain high cement content, (15 to 30%). Resulting in high lime content. More than 2.5%. Forms low melting compounds such as anorthite, CaO, Al2O3 twice SiO2, CaS2 inside 1553 degrees Celsius. And gehlenite that is twice CaO, Al2O3 SiO2. In short, it is written as C2AS. C2 is at 1583 degrees Celsius, and due to high lime content, it forms low temperature eutectic. Low temperature eutectic 1380 degrees Celsius. These castables require high amount of water require high amount of water for casting. Eight to 15% for casting, resulting in high porosity and low density. High porosity low density and low CCS, cold crushing strength, lower. Since these castables have high porosity and lower cold crushing strength, due to high porosity, Drag resistance is poor. These castables slag resistance and thermal spalling resistance are poor. Cold crushing strength in the intermediate temperature range, that is 250 to 800 degrees Celsius, are poor. Cold crushing strength in the intermediate temperature range strengths are poor. Intermediate temperature range, that is 250 degree to 850 degrees Celsius are poor. So due to high lime content, high temperature load bearing capacity is also poor. Due to high lime content, these castables have poor thermomechanical properties. Now, these are some of the drawbacks of conventional castables. To overcome these drawbacks, new generation castables were developed. To overcome the drawbacks of conventional castables, New generation castables were developed by lowering cement content, CaO contents. To overcome these drawbacks, new generation castables were developed new generation castables that having low cement contents. Low cement castable was developed for the first time in France. Low cement castable was developed for the first time in 1969 in France. Patent number 6934405. This is France patent number. Low cement castable was developed for the first time in 1969 in France. Now the concept of low cement castable or new generation castable concept is adoption of proper granulometry lower cement content and incorporation of ultrafines of ultrafine particles and suitable deflocculants led to the development of new generation castables. That is low cement castables, ultra low cement castables, or even no cement castables. They are developed later on. Now the concept is these refractory castables contain calcium aluminate cement. Castables contain calcium aluminate cement. In short, like calcium aluminate cement. In conventional castable, the bond is calcium aluminate cement. Bonding system. In conventional castables, bond is only calcium aluminate cement or alumina cement. For making low cement castable or ultra low cement castables, cement content is replaced by ultra fine particles. For making new generation castables, a part of cement is replaced with ultra fine powders or particles. Yeah, ultra fine particles. .15 micron. And some deflocculants are added. So bonding system of new generation castables or low cement castable or ultra low cement castables is calcium aluminate cement. Part of calcium aluminate cement is replaced by ultra fine particles less than 1 micron, and some deep flocculants are added to disperse the particles, fine particles. So this is the bonding system in new generation castables. This is the bonding system in new generation castables. Cement content is vary from 0 to 6%. 0 for low cement castables, and in between there are low cement castables, ultra low cement castables, and medium cement castables are also there, containing 8 to 10% cement. This is the bonding system for new generation castable. Bonding system for conventional castable is calcium aluminate cement, and new generation castables, a part of calcium aluminate cement is replaced with ultra fine powders particles, and some suitable deflocculants are used to disperse the fine powders. Now the formulation of conventional castables and new generation castables we will discuss. In conventional castables, so these are aggregate particles they are aggregates and in between aggregates voids are created. These are void space. These are void space in between aggregates. These are the void space. In conventional castables, these voids are filled with water. This is conventional castable. And this is the concept of new generation castables. New generation castables are LCC, ULCC, ultra low cement castable, NCC, no cement castable, or ZCC, that is zero cement castables. In conventional castables, voids are filled with water. In case of conventional castables, voids created between the aggregate particles are filled with water. Whereas in case of new generation castables, wide space are filled with ultrafines particles. For ultrafine particle generally fume silica is used. Fume silica is a form of amorphous silica. So this is the difference between the formulation of conventional castable and new generation castables. Wide space between the particles, fine particles filled with water, so it requires more water. Here, in case of no cement castable or new generation castables, wide space are filled with ultrafine powder, microfine powders, and so it requires less water. Here, conventional castables require water for casting. Eight to 15%. Whereas in new generation castables, water for casting is 3 to 5%. Now, due to low water content, its porosity is lower and hence strength are very high, better than conventional castables. And other properties is spalling, slag resistance, high temperature strength, that is hot modulus of rupture. These values are much better in case of new generation castables as compared to conventional castables. Only thing is that for mixing new generation monolithics or castables, you need mechanical mixer. And in this case, you may also mix manually with hands. But here, mechanical mixer, that is planetary mixer or any other good mixer, is necessary for mixing new generation castables. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.